This video will be about transforming functions. So I'm going to start out with a little introduction here. Let's say I have this graph that is my function f of x. Alright, so there's my f of x. I can take this function and I can do a bunch of different things with it. I can take it and I can move it left. Let's see, how many units did I move it? 1, 2, 3, 4, 5, 6 units, or 5, I can count. You can move it up. We can move that function down. We can move that function left. We can do a combination of moving them up and down, up, left, right. So for example, I can move it left and down. Okay. So there's a bunch of different things I can do with the function. I can also stretch it so that it would maybe go longer or taller. I can take the function and I can reflect it. So we're going to take a look at all the different steps for doing a transformation on a function. The first type of transformation that we're going to look at is horizontal and vertical translations, otherwise known as shifts. We also call them slides sometimes because you're taking the function and sliding it left, right, up or down, or a combination of left or right and up and down. Alright, so if I have f of x plus h, what that does is it shifts f of x left h units. Alright, so what that would look like is something where I have a graph. Let's say that. There we go. I have this graph here, and maybe I just have this line. We'll do something really simple. If this is my f of x and I want to find f of x plus 6, what I just need to do is take each one of my points here. So I have the point 1, 1. I'm going to shift that to the left 6 units. So I'm just going to move that 1, 2, 3, 4, 5, 6. And shift this point left 6 units. 1, 2, 3, 4, 5, 6. So that line right there is my f of x plus 6 because I shifted it to the left 6 units. My next kind of shift is where I have f of x minus h. What that does is it shifts f of x right h units. So each one of these points, here's my f of x. Let's say I want to find f of x minus 3. I'm going to take each one of these points and move them to the right 3 units. And then we have our shifted to the right graph. Now something in an actual equation that would look like it's shifted left or right would be where I have let's say I would have x squared, and then the transformation would be something like x minus 2 squared, or x plus 5 squared. That would be taking the x squared function and adding 2 on the inside of the square, so those would be shifts that are left or right. My next shift would be a vertical translation. And what it does is if I have f of x plus k, it's going to shift the entire f of x function up k units. And I like to do this by points. So let's say that this function right here is my f of x. Then if I want to find, let's say f of x plus 4. What I would do is I would take each of these points and move them up 4. So I'll start with this left point and move it up 1, 2, 3, 4. I will take this point and move it up 4, and this top point up 4, and there is my new f of x plus 4. I just see how this whole thing just gets moved up. So that gets, all of it gets pulled up, all the way up. Alright, so the other translation that relates to this would be a shift down. So let's look at what that is. Alright, so this one will take my f of x. I'm just going to keep using the same graph here. And let's say I want to find, f of x minus 3. Then we would take our f of x function and move it down 3. Each point will get moved down 3. So that's how we would shift that, moving it down 3. So this purple one would be my new transformation. All right, the next transformations we're going to look at are reflections. Okay, the first reflection that we use is a reflection over the x-axis. So if I have negative f of x, something that would look like is if I had an x squared function and then it really showed negative x squared, where it's on the outside of the x. That would reflect the entire function f of x over the x-axis. So to do this transformation, I'm going to take each point here and I'm going to reflect it directly over the x. So that's 2 up, so I'm going to go 2 down. Same with that point, and that's 4. So there we go. And then we connect it after that. So it's like putting a mirror on the x-axis, and it will show exactly the same over on the other axis. The last reflection that we will see is if I have f of negative x, that will reflect the f of x function over the y-axis. So here, this transformation was negative f of x. Notice that this f of x represents the y value, so I'm making the y value negative, which means going from positive y values to negative y values. Now here on this f of negative x, I'm making my x values negative, so that's why we would reflect it over the y-axis, because we are changing the x values. So to find f, let's go a different color, to find f of negative x, we will take this and reflect over the y-axis. Like that. So on this left graph right here, that is a reflection over the y-axis, which means we're changing the x values. On the red one down here, it's a reflection over the x-axis, which means we're changing the y values. One thing to be aware of is what this would look like on a standard graph. If you had, for example, the square root of x, if I were to take that inside and negate the x, just the x, not the whole square root, but just the x, that would be changing the x value so it would reflect over the y-axis.